Thank you, Toby. Yeah, I'm here to tell you a little bit about how we use our data at King, the kinds of things that we do with it, how we organize it. A few brief words about King, just to start with. We make games. Our most famous and popular is Candy Crush Saga on the left there, but there's close to 10 of our games on the app stores now. And they're a lot of fun, so I encourage you to play them. A few words about King. We've, over the last couple of years, grown a very large player network, 348 million monthly players now, and every day that's about 1.4 billion game plays. So there's a lot of activity out there. We've spread into multiple studios now, mostly across Europe. These 1.4 billion gameplays generate a lot of data for us, and so I'm going to try and tell you what we do with that. There's sort of four things I wanted to cover today briefly, a sort of whistle-stop tour of different aspects of using data. So the first piece is how do we use it to kind of ensure that our games are fun for years on end. And the strange thing has happened in the mobile games industry over the last sort of couple of years, compared with the first few years of the app stores, which was that in the first few years of the app stores, there were different games at the top of the charts all the time. And that's kind of, it's very different now. And so sort of between ourselves with Candy Crush and Supercell with Clash of Clans, things have been pretty static at the top of the charts for a long time. There's obviously, games do enter and get close and so on, but these games seem to have incredible longevity. And so I'm going to tell you a little bit about how we try and accomplish that. And then I'll touch on some brief stuff around predictive analytics, machine learning. Very briefly talk about how we organize our data, so from a kind of tech point of view, and when some of the challenges that we have there. And then finally, a sort of topic more on the data science side of things about some of the complications that we have in dealing with the data and making good decisions. So super quick whistle-stop tour of four topics. So as I said, Candy Crush has been close to the top of the charts for a couple of years now, since its launch. And how can we keep the game so popular for so long? And so there's a lot of different things there. But a key thing that I wanted to touch on today is about the levels. So all of our games have hundreds and hundreds of levels, and we constantly add new content to them, new levels. And so it's getting that kind of sense of progression right is very, very important. And when we talk to our players and ask them why do they like our games, the key thing that they always say is that they enjoy the challenge of the games. And so in our games, the only challenge is the levels. So somehow getting that right is very important. And there's one level in particular, Candy Crush level 65, which has become slightly infamous. And if you Google Candy Crush level 65, you'll get about 6 or 7 million hits for it. There's a lot of people who are talking about it. Here's a quote on one of our fan pages from one of our players at the bottom here. After 2 months at 65, I finally cleared them all. So excited, I screamed at my hubby to come see. Then it said I failed. I never noticed, besides clearing the board, you needed at least 150,000 points too. Since the game ended, I have no idea how close I was to that total. I cried myself to sleep. It's been another week and I'm still not off level 65. Ugh, so frustrating. So people have very, very strong emotions around these things. The key thing when we looked at this data, which is a couple of years old now from this particular analysis, was, can a level be too hard? This level had an average number of attempts of around 120 or so. And that's an average. So there's many players making 300, 400 attempts at a single level in a game. And had a 50% dropout rate, which is obviously alarmingly high. But on the other hand, if we wanted to be sort of hard-nosed financially, we were making a lot of money on this level. But the key thing here, when we come back to this picture of how do we keep our games popular for very, very, very long, is to understand that the way to look at all of this is very much in terms of the long term. And we are far better off as a business to make levels like this substantially easier, because that will keep people in the game for much, much longer. And despite the sort of that kind of motivational aspect of getting through a really tough level, you can make this level quite a lot easier, and it's still pretty hard to get through. And so it's really that long-term perspective that we want to look at, the behavior of our players, their play, their when they spend, and all those sorts of things across the very long term. And now today, Candy Crush has 750 levels, and so there's enough content there that if you get the game right, people can happily play that game for years on end. And so it's getting this sort of balance, the flow through the game, right, so that you feel that there's always challenges in front of you, but you don't feel like you're ever going to run into some sort of insurmountable block. And that's a sort of key thing. So we spend a lot of time trying to get this sort of stuff right. A tremendous amount of time, actually. So there's all sorts of other different aspects to this. We spend a lot of time really thinking about our players. It's very easy when you run experiments in games or in whatever industry you're in to kind of end up in a mindset of just sort of testing, is feature A or feature B better? And we slip into that mindset sometimes at King, but we always try and step back from it. And what you really want to understand is, what's the player experience here? What do we know about what the player wants to achieve, wants to do, how they want to behave here? And let's, rather than test feature A versus feature B, let's think about testing an experience for the player that will change something about their behavior, about their motivation, about their frustration. And if you approach things from that point of view, you tend to end up designing much better experiments in your games rather than very sort of simplistic kind of feature testing. So we spend a lot of time on that stuff. There's other sort of key things in here. Candy Crush 700 plus levels, you need to introduce new stuff in there. No matter how wonderfully you balance the ebb and flow of difficulty, you need to add entirely new things as you progress through that game. And so we spend a lot of time on that too. Really important to analyze things in the right way, and that'll be the last topic I touch on. And then another thing that we do is we build out, so for example with Candy Crush, we just launched last week, Candy Crush Soda Saga, a kind of sister title, which builds on that theme and adds a sort of new layer of richness, and is sort of a different opportunity. For some people who have maybe lost interest in Candy Crush, this can be something new that's familiar but different. And for other people, they can play both at the same time. And so this is how we're trying to sort of extend that sort of long-term feel there. That's all I wanted to say on that topic, to move on to the next one. How to do good stuff with sort of machine learning and predictive analytics. We get a lot of data, and it's mostly of that sort of basic form up there, that a particular player on a particular device tried a particular level, they got so and so many points, they succeeded, they failed. Then there's a variety of other sort of metadata around that, but it's pretty simplistic stuff. But obviously, there's a lot that you can derive from that if you look at it in the right way. And there's obviously all sorts of great questions here that we would love to have the answers to. Are these things stuff that we can meaningfully and accurately predict? And so we spend a fair amount of time kind of trying to answer those questions there. And the key point I wanted to really say today is that actually these things are super hard, and most things end up failing this test. So for something to be genuinely useful, obviously it needs to be predictable. So you need to be able to predict it in some way. And unfortunately, people are not the most predictable things. So that's a big hurdle to start with. Can you actually get any kind of useful predictions out? And then secondly, your prediction needs to be actionable. So the easiest way to explain what I mean there is to give you an example where things are not actionable. So the typical thing that happens when you ask someone slightly naive to build a predictive model of churn is they'll take a big slab of data, they'll feed it into some wonderful machine learning models to build some predictions, and then they'll say, okay, so I'm going to use this data to predict, is the player coming back in the future in this other slab of data? And what the wonderful models will spot is that the best prediction of someone not coming back in the future is actually that they haven't played for the majority of the data you fed in. So they churned long ago. So that's just entirely not a useful prediction. A useful prediction where you can actually act on it in a good way is one where the player is active right now, but I'm predicting that they're not going to come back after this. And that's when you can maybe do something. You can interact with them, you can intervene in some way and encourage them to come back. But if they already haven't played for 2 weeks, about the best you can do is send them an email, and that's really not a very helpful form of communication that's going to achieve much. So things need to be predictable, need to be actionable, and they need to be effective. You may have the most wonderful, actionable predictions in the world, but if the player is completely fed up and not interested in coming back at all, and nothing you do will change that, then you're not going to accomplish anything either. So those 3 hurdles, each of those hurdles individually is pretty hard, and the combination of them means that in the vast majority of cases, not very much comes out of this. So there's really big challenges here. Okay, I want to move on to the next topic. So it's a bit more on the tech side, our data. This is running up to the early part of this year, how much data we pull in a day, compressed, so it's now up above 600 gigabytes a day coming from all of our games. And you can see it spiked up around here. This is when we launched Candy Crush on mobile, and that led to the sort of huge explosion in our business. So how do we deal with all of this? Well, a long time ago, we actually just used ClickView, which is a business intelligence tool, as our database. And that coped fine when there was very little data. That obviously gave up pretty fast, though. It's, we were abusing it for the wrong purpose, as one tends to do when you're kind of small and starting up. We then switched to an InfoBright database, which was pretty good and scaled for a while, but as our volumes grew, that kind of gave up too. And so then we put Hadoop in, started off with a 10-node system, and we've been growing that ever since, and that's been serving us extremely well. So we're very pleased with that, and we continue to expand that cluster and optimize it in various ways and upgrade the Hadoop system and so on, and it's really working nicely. However, that doesn't do everything. And so what we've found alongside this is we've introduced another tool into the puzzle here. So this is a sort of very schematic, high-level view, obviously, of our pipeline. So the games produce event data. We put that into Hadoop. We mostly use Hive as the sort of SQL query language on top of Hadoop. And that's what we were using. Data scientists were reading things, were querying through Hive, and the reports were coming from Hive. We've moved to this, where we've put in this Exasol, which is a sort of in-memory database product. It's very, very fast. And so why did we see the need for that? And there are 2 very strong drivers for it. One was that just with the volume of data that we had, a lot of stuff that we were running against Hive was just too slow. Hive is great for storing Hadoop is great for storing huge volumes of data extremely cheaply. But for certain kinds of use cases, the speed with which you get your results out can be a little bit too slow. And the other thing was that our ETL, so ETL is the process where you transform your raw data into a nice, well-structured data model that sort of makes sense and represents the world in the way that you would like to view it, which in our case is a very player-centric view of the world, as opposed to the raw data, which is just time-stamped events that aren't connected in any useful way. So to transform those billions of events a day into a good data model on top of Hadoop was actually taking us more than 12 hours a day. So we would start the processing not long after midnight, and then it would be in the afternoon when finally we'd have processed 1 day of data, and we could then produce some standardized reporting. And then the standardized reporting took some time to build as well. And so pretty much you were getting your information about what happened yesterday sort of close to the end of the working day, which is pretty useless, really. So we put Exasol in, which was extremely fast as a system. So really this sort of hybrid architecture is working very well for us. So Hadoop on the left there, super scalable, very, very resilient, extremely low cost for storage. You can just store crazy volumes of data for very low priced. It's good at dealing with semi-structured data and other kinds of things, so it's great for all of that. And on the right-hand side, we put a subset of our data only into Exasol and use that to build the nice structured model extremely quickly. So the processing of a day of data for us is less than an hour now. And so it means all of yesterday's reporting is available early in the morning before people even get up. So it's a massive transformation for King to be able to do that. And the other thing is it's also very, very fast for data exploration. So a lot of what the data scientists want to do is explore the data, do all sorts of ad hoc querying, ideally extremely quickly, and then, okay, once you know exactly what you want to do and how you want to do it, then maybe you want to run that same query against Hadoop on a much larger data set, and you're happy for that to then take half an hour to return, because it's a very complicated thing that you're trying to query. But during the iterative development investigation process, having a kind of half-hour cycle is just not helpful. So it works extremely well for the data scientist use case as well. But that doesn't cover everything. So I just want to give you a hint of some of the challenges that we're now sort of wrestling with. I should say we have some other stuff in our data platform. We use Kafka for certain real-time stream processing to provide a real-time view of what's going on in our games, and that's extremely useful to us for when things go wrong, that we can catch them more or less instantly and then start fixing them. But we would like to, apart from that use, the rest of the way that we today treat our data at King is very much a daily batch process. And there's various reasons for why we'd like to move away from that. So we're currently sort of heading towards an hourly process, so we could update every hour on a more sort of fine-grained basis, and we think we can manage that pretty effectively, we think, just using the architecture we have already. It complicates quite a few things, but I think it'll work fine. However, there's sort of there's certain limited number of use cases, I have to say, where we'd like to kind of start narrowing that gap further, and sort of get, in some cases, even towards real time. So the question is kind of, what fits in that gap there? And again, in a spirit of kind of hybrid solution where Hadoop's really good for some stuff and Exasol for us is really good for other stuff, whatever we fill that gap with will undoubtedly also have its pros and cons, and it should be designed to be very good for what you're trying to do with it, what the business demand is there. And so this is just one of the things that we're kind of wrestling with over the coming year, and just sort of investigating various tools and technologies for what we might do to bridge that gap in a good way. So maybe in a year's time I might have some answers there for what that'll be. So that's our challenge for the technical side of the team at the moment. So last topic today in my whistle-stop tour is sort of on the data science, the statistical subtleties side. So we run quite a lot of experimentation, A/B tests, and things like that in our games, and it turns out that even at our scale of data, where we've got our 300 plus million monthly players, it's not straightforward to draw clear-cut, statistically significant conclusions from things. And I want to explain a little bit why that is. Here's a sort of a thought experiment for you to help sort of illustrate the problems. So what we find is, let's imagine we're running an A/B test here. So it's this huge population, we split them into A and B, and then we observe that on average, Group B has 4% higher revenue for us. Great, Group B must be better, sure. Except, well, maybe not. Would you really trust these results, for example, if you had these two individuals in your population on the right? Well, perhaps not. So the core of the problem here is that almost anything that we measure in our business is extremely skewed. So most of the revenue comes from a small percentage of the players. Most of the social messaging comes from a small percentage of the players. Even time spent playing is extremely skewed. And fundamentally, the reason that's a problem is sort of illustrated in the graph on the right here. So when things are not skewed, if they're nice normal distributions, that's the lines all shown in solid there, your mode, median, mean, they're all pretty much the same, and they represent most of your players. So if I take some sort of error bars around any of these, mode, median, or mean here, and look at all the players in there, that's a huge number of players. So that the average is representative of what's going on out there in the real world. When you have a very skewed distribution, so that's the dashed lines there, the mode, median, and mean are all over the place. And whatever one of those you want to look at, and then take some error bars around it, that only now represents a very small sliver of your population. And so looking at any of those numbers, you're throwing yourself open to getting all sorts of biases. So there's a lot of complicated. One has to approach this sort of analysis in a much more subtle, complex way. And then on top of these sort of, on top of all this skewness in the data, what we also find is that all of our data there are naturally very many biases in what goes on. So basically, and by biases there, I mean that basically there's a sort of self-selection by the players. So just give you a simple example, if you show some new feature, you release some new feature, there's some new button or something in the game, and you show that to some people, or maybe it's a little advert for a new game that you're releasing. Any player who chooses to click on that is immediately self-identifying themselves as someone who's keener on games and likes exploring games, and is undoubtedly, every metric that you look at for that player will be higher. The average amount of time they spend playing is going to be higher compared to people who don't click on that button. So as one makes these sort of changes to the games and explores them, you very often get confronted by these big self-selection problems. And when you can run good A/B tests, part of those problems go away. But sometimes you can't always run good A/B tests, particularly when you're talking about social features and things like that. It's not very helpful to slice your population in half or in different chunks, and then try and run tests on different kind of social features where your friend might be in a different segment to yourself. That creates a sort of horrible user experience. So I'm not going to give you any answers to this today because it's all a bit complicated. However, super important to hire great data scientists who combine the sort of right stats wizardry so that they eat this stuff up for breakfast, and combine that with the right business insight so that they can actually answer the right business questions in the right way. So that's the fourth topic I wanted to cover, and I think I've managed to do so with some time for some questions. So thank you.
Do we have any questions for Vince?
You mentioned that you used your predictive models to act on players while they're actually playing the game. I was just wondering if you could give some examples of the kind of actions you take.
I suppose the key, so one of the simple actions that we take is, a key part to deciding what a good action is to understand not just, hey, I'm predicting this player's not going to come back, but understanding why they're not going to come back. Is it that they're stuck on a particular level in the game, and like that level 65, and they've been stuck there for weeks and weeks and weeks, and their gameplay has gradually kind of gone down? Then it's pretty clear they're kind of frustrated, and you should do something to help them through that level. So that's one sort of thing that we can do. But in other cases, maybe that situation isn't at all true, and they're not stuck at any level. They just, they only play once a week or something. They're just not really into it. Well, then you have a different thing you should do for them. Helping them out on whatever random level they're on is a complete waste of time. Maybe you should suggest that they play a different game. Maybe it's just that they're not playing this game enough, and just try and do something which will encourage them to play a bit more often, and they'll get really into it. So it's about, those are the kinds of things. It can be very simple sort of messaging or whatever, just to, but it has to be, relevant to the context, and that's something I didn't really mention there at all. It's you've got to understand why something has happened, not just that it is happening.
Thank you.
Anyone else? A question?
Hi. So, you've got the data scientist, but also there's quite a lot you're talking around, which is psychology. Is that also the data scientist, or do you have a separate team of mad psychologists?
That's also the data scientists. So we try and hire. And we have about 50 data scientists at King now, maybe even closer to 60. And we try and hire people with a very broad. So across that group, there's people who are PhDs in stats and all that kind of stuff. But then we try and hire people also who've maybe had kind of behavioral economics background or those kinds of things, which do come more into the psychology side. And I think we even have someone who's at least done from a kind of stats psychology background. So it's definitely helpful. Yeah.
Candy Crush is one of the only games that you can actually play offline. How does that impact your real-time metrics, and how important has that offline play been to the success of Candy Crush, and how do you analyze that?
Those are very good questions. Yeah, we've always designed our games to be played offline, and the reason for that, I suppose, is that the types of games that we make are ones that you can pick up and put down in just a few minutes at a go. And so they're sort of ideal thing for people like on their commute, when they're on the underground or on a train where, things are never quite as reliable as you'd like. So that's, we think, a key thing from a player behavior point of view, and that's borne out by when we sort of talk to our players and stuff like that. When do you use these games? And then we can see in our data that there are, people who play regularly on their commute and that kind of thing. So it obviously messes with your real-time view of the world, because that data will be batched up on the device and then pushed over later on, and so you get weird, sort of timestamp synchronization issues. I suppose, honestly, we haven't really worried too much about it, I have to say. I'm sure one day we will, and one day we'll be confronted by problems that are caused by it. But so we've just designed the data collection process to be robust to that, and kind of let everything else sort of get on by itself. It also does pose complications when you do A/B testing on mobile, because you need to make sure that for a player to experience a particular test group, not only have they to have been assigned to that test group, which will be done on the server side, but that information needs to have reached the client, possibly together with any relevant sort of assets or other kind of parameters. And so you need to understand that there's a difference between assigning someone to a group and them actually experiencing that behavior, and make sure you analyze the correct one.
Any more questions? Okay, this should be the last one, I think, so we can move on.
I guess the number of messages that is pouring onto a player could be quite immense, right? Social groups and so forth. I wonder if there's too much noise actually for churn prediction, or for the kind of things that you want to predict.
Certainly, there's loads of noise. Totally agree. Our games are. Many of them are they're all connected through the Facebook platform if players choose to connect through that. In that case, the messaging is sort of in the context of a huge amount of noise, and of Facebook's algorithms filtering and deciding what should be shown and what shouldn't. That definitely complicates things. And certainly, we feel that we need to be very, very careful as to what messaging we actually push to players, because you can obviously easily spam people. We've been in the kind of combination fortunate, unfortunate position of our explosive growth as a business last year meant that we didn't really have time to develop a lot of the clever stuff that we'd like to do in this area, so we weren't spamming people with messages because we didn't have the ability to do so. But now that we've sort of caught up with that, it's very much about, for players playing several different games, different platforms, whatever, what's the right message at the right time, and not, here's your 10 messages of the day, which you would otherwise end up getting.
Okay, thank you very much, Vince.
Thank you.